Today we're going to talk about how to add and subtract fractions. So if I had two pizzas and I have 1/4 of this pizza left and 2/4 of this pizza left, how many pieces of pizza do I have altogether? Well, I've got the 1/4 plus I've got 2 more quarters. Well, that would be 3/4 of a pizza altogether, wouldn't it? Because both of my denominators are quarters, when I add them together, I just add the numbers on the top, the numerators. And I don't do anything with the numbers on the bottom because I'm talking about quarters of a pizza. And so my answer is still quarters of a pizza. Okay, what I do add is the numerators. 1 plus 2 equals 3. Okay? So let's try a couple more. In both cases here, I have fifths that I'm talking. So my answer is still going to be fifths. But how many fifths do I have altogether? Well, I had 1/5 plus 2 more fifths is 3/5, right? I don't add my denominator because my denominators are the same. It's still fifths that I'm talking about. Okay? A picture that would go with that would be if I had a pizza divided into 5 equal parts and another pizza divided into 5 equal parts, and I have 1 of those fifths plus 2 more of those fifths. I have 3/5 still, don't I? Okay. All right, so let's add 1/3 plus 1 more third. Well, I'm still talking about thirds, so my denominator doesn't change, but I have 2/3, 1 plus 1 in the numerator. Okay, so 3/5 plus 1 more fifth is still fifths, and I have 3 plus 1 more, I have 4/5. Okay, I have 2 sevenths plus 3 more sevenths is still sevenths. How many sevenths altogether? 2 plus 3, 5 sevenths. Okay, I have 2 11ths plus 4 more 11ths. I still have 11ths. How many 11ths do I have? 2 plus 4, 6 11ths. So adding fractions is very easy as long as your denominators are the same. That is the key. It doesn't even matter how big your denominator is. As long as your denominators are the same, okay, that's called a common denominator. So I have 134, 18 134ths, and I have 45 more 134ths. So I'm still talking about 134ths. How many altogether? 18 plus 45. Well, 8 plus 5 is 13, 4, 5, 63 134ths altogether. Okay, and the next one is 67 456 plus 49 456. Well, I still have 456. Okay, and how much is 67 plus 49? 116. Okay, and in the third example, I'm talking about a pie that's been split into 1,567 pieces. Ooh, I'm getting a very small piece of this pie. Okay, but I'm still talking about a pie that's been split into 1,567 pieces. How many do I have altogether? Well, if I have 67 pieces plus another 78 pieces, I have 145 pieces altogether of those 1,567 pieces. Sometimes I'm even asked to add 3 fractions, but again, the same thing holds. If I'm talking about 17ths and all 3 of them have the same denominator, I'm still talking about how many 17ths I have. 3 plus 1 plus 2 is what I would add in my numerator. That's 4 plus 2 more, which is 6. 6 17ths altogether. Same with the second one. I have 90/4, 90/4, 90/4. So I'm still talking about 90/4. How many do I have? Well, 5 plus 4 is 9, plus 7 more is 16. Okay, and the last one, I have a common denominator of 19 in each case. So I'm still talking about how many 19ths I have. 3 plus 2 is 5, plus 5 more is 10, plus 4 is 14. 14 19ths. Okay, subtracting is the exact same. As long as I have the same denominator, then my denominator does not change. Okay, so if I have 3/4 of this pizza, and then I'm taking away 1/4, that's why it's crossed off here. How many quarters do I have left? 2 quarters are left, right? So it's the exact same thing as addition. As long as you have a common denominator, your denominator does not change. You just subtract across the numerator. 3 minus 1 equals 2. So let's try a couple of these. We have 8ths in both cases, so my answer will be 8ths. I have 7 minus 1, 6. Okay, so 7/8 minus 1/8 is 6/8. Okay, same thing with 5/6 minus 3/6. Well, I'm still talking about 6. 5 minus 3 is 2. 3/5 minus 2/5. Well, I'm still talking about fifths. 3 minus 2 is 1. (11/8) minus 13/8. Well, I'm still talking about a pie split into eighths. 11 minus 13. Oh. Can I do that? You're right, it would go into the negative numbers, wouldn't it? That would be -2/8. Okay, what about 56ths? 10/56 minus 7/56. Well, I would still have 56. 10 minus 7 is 3. Okay, and the last one, I have 12 803s minus 5 803s. Well, I still have 803s. 12 minus 5 is 7. All right, let's have a look at another example where we have 3/4 of a pie plus another 2/4 of a pie. Okay, well, we're still talking about quarters. I'm adding and my denominator is the same, so it will stay quarters. But I have 3 plus 2 in the numerator, which is 5. 5/4? Is it possible to have 5/4 of a pie? Well, I hope you said yes, it is. 5/4 of a pie is the same thing as 4/4 plus 1 more quarter, which is 1 whole pie and 1/4 more, right? We know now how to convert from an improper fraction to a mixed number. So that shouldn't surprise us, okay? Okay, so let's have a look at this one. 5/4 plus 2 3/4. Well, I can't really add this right now because this one is an improper fraction and this one is a mixed number. Okay, so I need to convert both of them to the same thing, either both to improper fractions or both to mixed numbers. Okay, so let's convert this one, the mixed number, into an improper fraction. So remember how we do that? That would be 4 times 2. Remember, you multiply those two. 4 times 2 plus 3. 4 times 2 is 8, plus 3 is 11/4. Okay, plus 5/4. Okay, now we can figure out what this is. They're both fourths, so my answer will be fourths. What is 5 plus 11? 16/4. All right, let's try a couple of these. 3/5 minus 3/5. Oh, well, they're both fifths, so my answer will be fifths. Now I just subtract across the numerator. 3 minus 3, no fifths. 0/5 is the same thing as just plain old 0. Okay, let's have a look at 2/7 plus no more sevenths. Well, it would still be sevenths. 2 plus nothing is 2. 2/7 plus no more sevenths is 2/7. Okay, let's try this one. 3/8 minus no eighths. Well, it's still eighths. 3 minus nothing? 3. 3/8 minus no eighths is still 3/8. Okay, 6/7 minus nothing. Well, I could do this one in a couple of different ways. I could use that I know that 0 is the same thing as 0/7, right? So then I could do 6/7 minus no sevenths is still 6/7, right? But I actually wouldn't really need to, because 6/7 minus nothing is still just 6/7, right? Okay, let's have a look at this one. 1 2/3 plus nothing. Well, that's still 1 2/3. I haven't added anything to it. All right. So adding and subtracting fractions, as long as they have the same denominator, a common denominator, you keep your denominator the same, it never changes. You just add or subtract across the numerator. But what happens when you want to add 1/3 and 3/5? 1/3 plus 3/5 is not as easy to add because I don't have the same denominator. So when that happens, I need to make a common denominator. I need them both to have the same number in the bottom. Well, the easiest way to do that is like you did in your assignment yesterday, where you were making a whole bunch of equivalent fractions for 1/3. Okay, so let's do this one. Whole bunch of equivalent fractions. Now we know when we make an equivalent fraction, that means that whatever we multiply the denominator by, in this case 3 times what, gives me 6, multiplied by 2. I have to do the exact same thing then in the numerator. Multiply it by 2. 1 times 2 is 2. So that means 2/6 is equivalent to 1/3. Okay? Then, in order to figure out the next one, I have to say, okay, what did I multiply 3 by to get 9 this time? 3 times 3, right. And so on the top, I have to do the same thing, multiply by 3. So I have 1 times 3, which is 3. So 3/9 is also equivalent to 1/3. Now once I've done that many, I can start to see a pattern in my numerators and in my denominators. In my denominators, the number on the bottom, it looks to me like I'm skip counting by 3s. 3, 6, 9. There's another word for that we've been talking about in the last few weeks. We're finding the multiples of 3, aren't we, in the denominator. So 3, 6, 9, I can just keep that pattern going, continuing to list multiples of 3. 3, 6, 9, 12, 15, 18, 21. Okay, that's the same thing as if I multiplied 3 times 2, times 3, times 4, times 5, times 6, times 7. So finding equivalent fractions is just finding multiples of your numerator and your denominator. Let's look at our numerator this time. Okay, we have 1, 2, 3. These are multiples of 1. We're just skip counting by 1s. So 4, 5, 6, 7. There, now I have a whole list of other fractions that are equivalent to 1/3. Let's do the same thing with 3/5. I can see that my denominator is going to be multiples of 5, right? 5, 10, 15, 20, 25, 30, 35. Let's do the same thing in the numerator. It will be multiples of 3. 3, 6, 9, 12, 15, 18, 21. All right. Now we're going to look and see if we can find a fraction that is equivalent to 1/3 and a fraction that is equivalent to 3/5, but they have the same denominator, a common denominator. Look at this. 1/3 is the same thing as 5/15. Okay, so I can write that here. That's 1/3 is the same thing as 5/15. And 3/5 is the same thing as 9/15. So I'm writing it under 3/5. Okay, because those two fractions are equivalent to the original two. Okay, but the beautiful thing about them is they have the same denominator. So that means now I can add them. They have to have the same denominator in order to add them. Okay, so this time I can add 5/15 plus 9/15. It's still going to be 15ths. How many 15ths is it? 5 plus 9? 14 15ths. And that would be my final answer. Okay, so when you are trying to add fractions that do not have the same denominator, you need to find equivalent fractions that do. And once you have that common denominator, then you can add across the numerator. The same goes for subtraction. You have to have a common denominator in order to subtract. Okay, so the lowest common denominator of two fractions is the lowest common multiple of those denominators. So that's why we made our list of multiples. Okay, so let's try this. 2/3 plus 1/5. Well, I cannot add that because I have thirds and I have fifths. It's like trying to add apples and oranges. I can't do it. Okay, so let's make our list of equivalent fractions for 2/3. Okay, so my numerators are going to be multiples of 2. 2, 4, 6, 8, 10, 12, 14, and I just can do a few, and we'll see if we have enough, if we can find a common denominator. Okay, my denominators in each case are going to be multiples of 3. So 3, 6, 9, 12, 15, 18, 21. Okay, let's do the same thing now for 1/5. We'll find equivalent fractions for 1/5. Well, my denominators are going to be counting by 5s, multiples of 5. 5, 10, 15, 20. Oh, I can stop right there because I can see I'm going to have a common denominator of 15 in both cases. Okay, let's do our numerators. It's going to be multiples of 1. So 1, 2, 3, 4. Okay. Now looking here, I can see I have a denominator of 15. I have a denominator of 15. So I can use those two equivalent fractions. Instead of 2/3, I'm going to use the fraction that is equivalent to it, but that is 15ths. So that it'll be the same as this 15ths. So that's 10 15ths. And this 1/5 is 3 15ths. Now I can add those together because I have a common denominator of 15. So my answer will still be 15ths. 10 plus 3 is 13 15ths. That's my final answer. Okay, let's try 2/3 plus 1/4. Well, again, I cannot add them the way they are because they don't have the same denominator. So let's get a list of equivalent fractions for 2/3. Well, numerators are going to be skip counting by 2s. 2, 4, 6, 8, 10, 12. We'll see if that's far enough. We may have to add more. We'll see. On the new denominator, we have a 3, so we're going to be looking for multiples of 3. 3, 6, 9, 12, 15, 18. Okay, let's do the same for 1/4. Multiples, or sorry, equivalent fractions. Well, our numerator is going to be multiples of 1, right? 1, 2, 3, 4, 5, 6. And our denominators are going to be multiples of, right, 4, 8, 12, or more, 16, 20, 24. Okay. Let's look at our list of equivalent fractions and see if we can find two fractions that have the same denominator. Common denominator. It's kind of like looking for common multiples, isn't it? Except we're looking for common multiples just in the bottom. Okay, there's 8/12 and 3/12. They both have a denominator of 12. Okay, so 2/3 was equivalent to 8/12 plus 1/4 was equivalent to 3/12. Okay, so because they have a common denominator of 12, I can add them. 8 plus 3, 11/12 all together. Okay, let's do one more. 3/4 plus 1/5. Well, 3/4, let's see, equivalent fractions. Well, we're going to be looking for multiples of 3 in the numerator. 3, 6, 9, 12, 15, 18, and in the denominator, it'll be multiples of 4. 4, 8, 12, 16, 20, 24. Okay, let's do the same for 1/5. Equivalent fractions would be, numerators will be multiples of 1. 1, 2, 3, 4, 5, 6. And in the denominator will be multiples of 5. 10, 15, 20, 25, 30. Let's see if we have enough to find a common denominator. Look just at the bottom numbers. Ooh, I see my least common denominator will be 20. Okay, so 3/4 is really equivalent to 15/20 plus 1/5 is equivalent to 4/20. So my answer will be 15/20 plus 4/20. Well, it's still 20th. 15 plus 4, 19/20. Okay, we do the exact same thing when we subtract, because to subtract we still need a common denominator. The denominators have to be the same. In this case they aren't, so again I need to look for equivalent fractions that are equivalent to 2/3. Well, my numerators are going to be multiples of 2. 2, 4, 6, 8, 10, 12, and my denominators are going to be multiples of 3. 3, 6, 9, 12, 15, 18. Okay, and I have to do the same for 1/5. Fractions that are equivalent to 1/5. Well, my numerators are going to be multiples of 1, right? 1, 2, 3, 4, 5, 6. And my denominators are going to be multiples of 5. 5, 10, 15, 20, 25, 30. Okay, let's see. Do we have a common denominator? Right. 15 would be my common denominator. Okay, so 2/3 is equivalent to 10/15 minus 1/5 is equivalent to 3/15. So with subtraction, just like with addition, 10/15 minus 3/15 is still 15ths. 10 minus 3 is 7/15. That's my answer. Okay, 1/4 minus 2/3. Well, 1/4. Let's find equivalent fractions. Multiples of 1. So 1, 2, 3, 4, 5, 6. And let's do the denominators. They will be multiples of 4, right? 4, 8, 12, 16, 20, and 24. Okay, 2/3. Well, my numerators will be multiples of 2. 2, 4, 6, 8, 10, 12. And my denominators will be multiples of 3. 3, 6, 9, 12, 15, 18. Do I have a common denominator yet? There it is, 12s. Yes. Okay, so 1/4 is equivalent to 3/12, and 2/3 is equivalent to 8/12. Ooh, 3/12 minus 8/12. Well, again, we go into the negative numbers. That's -5/12. Okay, and our last question of the day. 3/4 minus 1/5. Well, again, I can't subtract them. They don't have the same denominator, so I need to make equivalent fractions. So 3/4. My numerators will be multiples of 3. 3, 6, 9, 12, 15, 18. And my denominators will be multiples of 4. 4, 8, 12, 16, 20, 24. Okay, what about 1/5? Equivalent fractions will be 2, 3, 4, 5, 6. And in my denominator, it's multiples of 5. 10, 15, 20, 25, 30. Do I have a common denominator yet? 20s, right. Okay, so that means 3/4 is really equivalent to 15/20, and 1/5 is equivalent to 4/20, and 15/20 minus 4/20 is still 20. 15 minus 4 is 11/20, right.